Hello, I'm going to be going through the LeetCode question number 9 palindrome number. The question is the following. Given an integer x, return true if x is a palindrome. A palindrome number is just a number that, if written backwards, is exactly the same as written forwards. So he gives us the example of 121. That's a palindrome because 121 written from right to left is the same thing as from left to right. And 123 is not, because 123 reversed would be 321. So let's go through the examples the website gives us. I just went through 121. Negative 121 is not. That's because the negative is there. And any number that's negative will not give you a palindrome because the negative sign will just be like standing there at the end, which will give you an error. So anything that's negative, not a palindrome. Last example is x equals 10, not a palindrome. That's because reversed, that will be 0, 1. And that's not exclusive to 10. It's any multiple of 10 is not a palindrome. So basically anything that ends with a 0 can't be a palindrome because the first digit always has to be a number between 1 through 9. It can't be a number that starts with a 0. So 10, 20, 30, 500, 1,000, a million, whatever. All those numbers, not a palindrome because it ends with a 0. So we have to keep that in mind when we code. I'm going to go to my Eclipse because I like coding there and then just copy and pasting to LeetCode. If you guys want this code and I don't know, want to copy and paste it instead of just looking in mine and actually writing it down, there's a link to the code in the description below. So let's go through my code. I'm setting a integer. I'm doing it setting it to 1 to 1. It is a palindrome, and then I'm calling my function. What my first part of the code over here, what that does is just it checks for base cases, right? So as I said before, if x is less than 0, that means it's negative, which means that it's not a palindrome. Or if x modulus 10 is equal to 0. What this does is checks to see if 0 is the last digit, because anything that has a 0 as the last digit, and you take the modulus 10 of that, that would be equal to 0. So that's what this part of the code is doing. The only exception to that, though, is if the number is actually 0, because 0 is a palindrome. It's the same thing written backwards and forwards, and it does end with a 0, so that's the exception. So it checks if it ends with a 0 and is not the actual number 0. That's what this part is doing. So return false. Anything that's also, for example, a single digit number 4, 5, 8, 9, that's also a palindrome because it's the same thing written backwards. It's just the actual single digit number. Okay, this is the hard part of the code in quotations. What I'm doing here is I'm creating a variable called result, and I'm gonna go through the code with you so that you can see step by step what it's doing. It's checking if x is greater than result. In the first loop, it obviously is, because right now x is equal to 1 to 1 and result is equal to 0. So it goes inside the loop. Result is equal to result times 10, which is 0 times 10, which is 0, plus x modulus 10. As I said, what this does is it grabs the last digit of whatever your input is. So what this is doing, it's actually doing 0 plus 1, because 1 is the last digit. So I'm going to write here 1. That's what result is. And then x is equal to x divided by 10. Any integer, when you divide itself by 10, you just ignore, you just like sort of delete the last one, so the last digit, so it's now 122. And then you go back to the condition, 122 is greater than 1, And so result is equal to 1 times 10, which is 10, plus 122, because that's what x is right now, modulus 10, which is the last digit of x. So result is equal to 10 plus 2. So result is not equal to 2. And then this, what this does again is just deletes the last digit of whatever x is. And then we go back to the loop once again. However, right now it's not true because 12 is not equal to 12, right? X is not greater than result. They're equal to each other. So we exit the loop, and then we go to the if statement. If result is equal to x, then return true. So what my code is doing is that it's basically checking the second half of the integer and reversing it instead of reversing everything. Okay, it's just reversing the second half. It's just more efficient. So the first half is 12, the second half is 2 1, 2 1 reversed is 12. But what if the number is not even number, right? Right here, it's an even number. We know exactly where the half part of it is. What if it is an odd number? By odd, I mean it's a 3-digit number. There's no half, right? How can you divide the 2 in half? So this is what this part is doing. So if I went through this code here and I did x equal to 1 to 1 and I went through the loop, at the end of the loop it would actually be this. A result would be equal to 12 and x would be equal to 1. So if you plug result here and you divide it by 10, what this does is just like it did over here, it deletes the 2. So that would mean that this side of the equation would be 1 is equal to 1. It checks if 1 is equal to 1. In this particular case, of course, which is true. So this returns true. And this is an OR statement. So this is if the input is a even number. This is checking if it's not checking, but helping if it's an odd number. And then of course, if it's not true, return false. If the second half is not equal to the first half. We can do some tests here. Let's do 1 to 1. That's true. Let's add another 2. That's also gonna be true. Let's try negative. It's false. Let's try 0. True. Let's plug this into LeetCode and see if they accept my answer. Let's run the code. It checked for 1 to 1. It's true. Let's submit it. Let's see what it gives us. Perfect. 12 ms faster. Ran in 12 milliseconds. 64% faster. Which is funny because this ran faster now, but it's literally the same code. So anyway, that's the solution. Thanks you guys for watching. I'll see you next time with another question. Thank you.